Good afternoon. The topic that we are going to discuss today is connectedness. So, as the word itself, what is called connected? It means in graph theory, if there is an edge between any two vertices, then that vertices is said to be connected. And a graph in which it has no edges, then that graph is called disconnected graph or null graph or totally disconnected graph. Right? So in this connectedness, we can see the definitions: walk, path, and trail. So what is called a walk? A walk is an alternating sequence of points and lines beginning and ending with points such that each line is incident with vi minus 1 and vi. So let us consider an example here. So let us take a graph. So already we have discussed what is graph, what is loop, what is multigraph, what is pseudograph, and what is the degree of vertices. Now we are going to discuss connectedness. So let us consider a graph. So A, B, C, D. So this is a graph, and this graph is a graph with how many points? 4 points and 5 lines. So this is a graph with 4 points and 5 lines, and this is a simple graph. Why it is a simple graph? Because there is no loop and there is no multiple edges. Now we are going to see what is connectedness. So for example, let us see, I want to find a path from A to C. I want to find out a walk. So as the definition says, a walk is an alternating sequence of points and lines. So for example, if I want to start from A and I need to go to C, I can straight away go A to C. Or else what I can do, I can move from A to B, then B to C. So here you can have plenty number of walks. For example, 1 or 2. It is not restricted that you should have only one walk. So I'll just draw the graph again. A, B, C, D. So let us name the edges also. 1, 2, 3, 4, 5. Suppose if I need to find out a walk, so what I can do, I can find A, 1, B. This is a walk. Even A, 5, C, 2, B. This is again a walk. As the definition says, it is an alternating sequence of points and lines. So see here, A and B are points and A1 is a line, that is, it is an edge. So it is clear, a walk is an alternating sequence of points and lines beginning and ending with points. Here you see A and B, and similarly here also you can see A and B beginning and ending with points such that each line is incident with vi minus 1 and vi. So for example, if you consider the line 5, so the line 5, what is the predecessor of line 5? That is line 1. Here it is A, and that is what in general definition they have given you vi minus 1 and vi, so B. So now it is clear, a walk is an alternating sequence of points and lines beginning and ending with points such that each line is incident with vi minus 1 and vi. Now let us see the next definition, that is, a single point is a walk of length 0. A single point is a walk of length 0. Now see here we have given 2 examples for a walk. See, this is not only the example, you can have plenty, you can have n number of walks for this example. This is one of the example which I have taken. You can draw your own graph and find out the examples. You can find out walks. So now in the first example, you can see how many number of lines are there in that walk. There is only one line, so it is 1, the number 1. So therefore this is a walk of length 1. When you are considering the second one, there are 2 edges, there are 2 lines, 5 and 2. So the second example, it is a walk of length 2. Now a walk of length 0, a single point is a walk of length 0, means if you consider a single point, this is only one point and there is no edge here. So now what you can say, it is a null graph, it is a totally disconnected graph, and here the walk is 0. Here the walk is 0. Now see the next definition. A walk is called a trial if all its lines are distinct, and a walk is called a path if all its vertices are distinct. Let us see the same example again. So this is what the example which we draw already, A, B, C, D. Now I'll join this one. Okay, right. I want to find, I can write a walk. So now what is the definition of a path? If all the lines are distinct, then it is called a trial. So now we are going to see an example for a trial, right? So consider A. So let us name here 1, 2, 3, 4, 5. So for example, if I consider A, 1, D, 2, C. So trial means all the lines are distinct. So just to see here 1 and 2, there is no repetition of lines. So 1 and 2, so therefore this is a trial. Now what is a path? All the vertices are distinct. So just to see here, vertices A, D, C, all the vertices are distinct. So therefore this is an example for a trial, and this is also an example for a path. So this one example itself, it is clear that it is an example for a walk, it is an example for a path, it is an example for a trial, and also you can say the number of edges here, it is a walk of length 2, because the number of edges is 2 here. So therefore this is a walk of length 2. Now let us see the next definition. A walk is called a cycle. A walk is closed if v not equal to vn, and a closed walk in which n greater than or equal to 3 and all the vertices are distinct, then it is called a cycle. So again consider the same example. So what is a cycle? If you want to move from your home to somewhere, and you will come back to your home once again. So it means your starting point and your ending point is same. In that case it is called a cycle. Same way in graph theory also, if you start with the vertex v0 and you once again come to the vertex v0 itself, then it is called a closed walk. So a closed walk in which all the vertices are distinct, it is called a cycle. So just consider an example here. So consider this example A, B, C, D, right? So if you want to move from A, that is you will start from A, what you can do, you can go to B, then you will come to D, then C, then A. So you are starting from A, B, D, C, A. It means your starting point is V0, that is A, and your ending point, you are coming back to Vn, that is again A. So therefore this is a cycle. So this cycle, it is in general, it is denoted by Cn. Here this is a cycle with 4 points. So therefore this is an example for C4. Similarly, you can draw C5. You can just imagine this is C5. So A, B, C, D, E. So therefore this is C5. So and also the definition itself, it's clear. So this is C3. You cannot go with the C2. You can start, because the condition by the definition itself, it is n must be greater than or equal to 3. So it means you can draw a cycle. Minimum number of points for drawing a cycle is 3. So A, B, C. Right? Are you clear? So this is an example for a cycle. Thank you.